Hi, the plan for this week is to learn about Mars, Jupiter, Saturn, and Uranus. And we'll come back to the Earth's moon later. So today, let's learn about Mars. So this is a picture of Mars that we can see. Right. All right. So these are the two pictures of Mars that's taken in 2001 and 2001 September. So this first picture was taken June 26, 2001, and the second picture was taken September 4, 2001. Do you see any difference here? So here it's kind of land area, right? So you can see the land over here, but it's covered with something over here. So that's the dust storm that went over the Mars. So we call this as the global dust storm. And these pictures were taken by Hubble Space Telescope in 2001. And here's another picture. So this is a very famous picture that we can identify Mars, right? So this is a unique structure on Mars, Valles Marineris, right? And here's another picture that's showing a volcano. And there are so many human activities are going on Mars, and we'll talk about it in a few minutes. So this is the Curiosity space shuttle that's landed on Mars. All right, so the basic characteristics of Mars. Mars is about 0.107 times the Earth mass. So you see, like, it is smaller than the Earth mass. And the radius is about half the Earth radius. It's 0.531 times the Earth radius, right? So it's roughly half size of Earth. Then the density of mass is 3,934 kilograms per meter cube. And the sidereal rotation period is 1.026 days. That's 24.623 hours. It's roughly close to Earth sidereal rotation period, right? It's 24.62. It's a little off, but it's somewhat closer. And the albedo on Mars is about 0.15. Remember, on Earth it is 0.39. Then the average distance from Sun is 1.523 astronomical unit, right? So in kilometers, it's 200 million kilometers. And if you think about it in miles, it's 124 million miles. Then the surface temperature on Mars in average is minus 60 Celsius. These are the comparison pictures of the sizes of planets. So here's the Mercury, Venus, Earth, and Mars. So you see, like, Venus and Earth is somewhat in the same size, but the Mars is about half size of Earth. And Mars is the easiest planet to observe from the Earth. So most of the time when the sun sets, we can see a star, right? So that's Mars. So most of the time we can see it in the sky. So here, as in this picture, this blue color circle is the Earth orbit, and the red color one is the Mars orbit. So as you see, it's always following us, right? So even though Mars is in a longer distance from Earth than Earth, it's moving faster compared to us, right? So that's why it's following us. So here in 2005, November 7th, it's right above us. And December 2004, again, it's directly above us. Likewise, so it should be easy to observe in the sky. So its Mars can be seen at opposition when it's high in the sky at midnight. So it's even in the midnight, you can observe it. If you're using a telescope, you can even see the surface of Mars. So you need a strong telescope to observe the surface of Mars. As you know, Mars is always called as the red planet. So there are so many scientific movies developed on this idea. So if you have seen this one, it's colored in red color, right? So this is, we call this as the red planet. Why it is red? It's red because it's rusty, right? So the rustiness coming from the fine granite dust. Sorry, I'm sorry. I think I mentioned it incorrectly. So it's coming from fine grained dust. It's not granite, it's grain dust, like tiny, tiny pieces. And it's rich in iron, that's oxides forming rustiness. So that rustiness give us the red color, right? So this is finely grained iron, keep it in red color. So that's rustiness coming from that finely grained iron dust. So basically we call this as the red angry eye in the sky, but it's not an angry planet, but it looks like, right? So here, if you're observing the sky, you will be seeing Sagittarius. It's kind of a teapot shape, so we call it as Sagittarius teapot. And then you'll be seeing moon over here, and then the Saturn and Mars is over here. So it's somewhat closer to the moon. So if you're observing planets, it should be closer to the moon most of the time when it is rising time. A lot of the surface of Mars is also gray volcanic rock called basalt, and together with other minerals gives Mars its overall reddish look. So as I mentioned earlier, it does have mainly the redness coming from that finely grained iron dust. Also, it does have basalt. So together, it's making that reddish look. So apparent brightness increases as Mars get closer to Earth. So this is a observed Mars, picture of observed Mars in May. So apparent magnitude is -0.5. Mars in 2018. Okay, so it was different in 2020 depending on where the Mars located at. But in 2018 May, the apparent magnitude of Mars is -0.5. In July 31st, it's much closer to the Earth, so the apparent magnitude is -2.7. So it's much brighter in July than May. Then the Mars revolution and rotation. So the orbital period is 1.9 Earth years, that's 687 Earth days. What is Earth orbital period? It's 1 year, right? So here the Mars is taking a little longer to complete the circle around the sun. Then its orbit is very far from circular with a perihelion distance of 128.6 million miles and the aphelion distance of 160 million miles. So it does have a eccentricity, higher number of eccentricity than Earth, because it does follow a highly elliptical path. The intensity of sunlight changes by drastically, right? Remember, because of the eccentricity, the sunlight amount that we received onto the planet is varying. So here, due to this variation, like 128.6 million miles and 160 million miles, it's resulted in 40% sunlight intensity difference. And the rotational period is 24 hours and 39 minutes. So here, our solar day is 24 hours, right? So here, Martian solar day is 24 hours and 39 minutes. Then the rotation axis of Mars is tilted by 25.2 degrees. On Earth, it is 23.5, right? So on Mars, it's 25.2 degrees. Then the Martian seasons, similar to Earth seasons, only it is a little longer because it's following an elliptical path. Well, Mars has a tenuous atmosphere with little water vapor and few clouds. So the average air pressure on Mars is 0.6% of sea level pressure on Earth. And the escape speed from Mars is very similar to the Mercury's escape speed, which is 11,185 miles per hour. Then the Mars is much cooler, so it has retained the more massive molecule like carbon dioxide. So atmosphere molecule percentages are carbon dioxide does have 95% occurrence on the atmosphere, and the we can find 3% nitrogen and sulfur dioxide 0.03%. Remember, on Earth, the numbers are different, right? So we have carbon dioxide, the smallest amount, but Mars does have 95% carbon dioxide. How much oxygen does we have on Earth? It's about 20% oxygen, right? Here we cannot see oxygen, percent of oxygen on the atmosphere. So Mars atmosphere mostly coming from 90 carbon dioxide. All right, so please answer the following questions for the participation credit.